Good day, this is my submission for the video for the first assignment in embedded systems. So my project here is called the attitude meter and gimbal. By its name, it acts as a gimbal and an attitude meter both at the same time. So it uses an I2C for the accelerometer to read X and Y values. In this case, it's only a one-axis gimbal, so that's the X-axis only, and an interrupt for the button over here, pulse width modulation for controlling the LED lights and the servo motors, and the USART for producing or showing their values to the serial comms, and lastly the timers for, of course, controlling the pulse width modulations. So as for its functions, so first of all, the gimbal. So once you tilt this, the platform above will kind of adjust itself. So just here. Now, it may not be obvious, but the LED light grows brighter as the tilt grows. So this can be proven by connecting the LED to an oscilloscope. So as you can see here, this is slightly tilted. So as I tilt it more, its PWM kind of grows and shrinks. Now, as for the attitude meter, if you can see this in this LED screen, it gives the user kind of a rough idea of how much angle it's deviated from the horizontal. Also, for the interrupt and for the USART for serial comms, it's currently printing the raw X values and the servo angle, servo value. That servo value is actually the CRR of the timer. So it kind of ratios it out as I add or subtract it from based on the X value. So as you can see here, X raw is if it's lesser or if it's greater than 1,500. So keep adding 5 onto it until basically the accelerometer is in an acceptable range, which is plus minus 500, I think. So given that, for the button interrupt, so if I press this, it's going to go from active to paused. So, yeah, there we go. Paused. Now, if it's paused, it's not going to move at all. Also, even if it's in an angle, press the button, it's going to be paused. It's going to stay in that certain angle until you press it again, and it'll correct itself. There we go. As for your serial comms, you can see it's printing all the values needed and necessary. Actually, another feature is you can control how much or how fast is the adjustment going to be. So a part of the timer for the ARR and the CRR, so as you can see here, so plus and minus 5. So as long as you change that to like a lower or a higher number, it corresponds to speed. For example, maybe like 2. So theoretically, this will make it all slower. Just gonna and upload. So there's going to be a slower response compared to last time. So there we go. Thank you.